good morning, good afternoon, good evening. Thank you for joining this webinar. Today we'll be looking at why this is a great time for you to start to consider OpenStack as an alternative to VMware. And to do that, I have a guest that will accompany me today. He's an expert of VMware and vSphere, and we'll be talking about how we can compare VMware to OpenStack.
All right. And thank you, Daniel. Appreciate it. Hi, my name is Shiva. Good morning, good afternoon, good evening to everyone who is there here. And is it, Daniel, is it a great time to switch over to an open cloud based on OpenStack? Let's see that, right?
Yeah, sure, definitely. Let's see that. What we have planned for you today is to look at the various capabilities of both platforms. We want to understand how we are going to provision the cluster and services for VMware and for OpenStack. We also want to compare the compute services, network services, and storage services. We'll talk a little bit about the deployment topologies and the various options we have for active-active or active-passive. Security and LifeCycle is also very, very key. And then we'll talk at the end on the next steps. So Shiva, tell me a little bit more about how you would do that with VMware vSphere.
Yeah, so before I was going to get there, Daniel, I just wanted to, I started looking at OpenStack platform because of the recent acquisition of VMware by Broadcom. And, I just wanted to know what are the alternative options that I have. And that is the kind of context I started looking at, other alternative solutions, right? And from that perspective, I just want to, over all these years, I've been having, as you said, I have had extensive experience building private cloud platforms with VMware technologies, right? So I wanted to see OpenStack from that context of, compare and contrast some of these VMware vSphere technologies and, things around VMware vSphere that enable somebody to build a private cloud platform, right? Mm-hmm. Now I'm going to ask you from that perspective of how I see OpenStack platform today, so that I can relate and learn, whether it is easy, whether it is complex, how difficult it is for us to transition from a VMware-based private cloud platform to OpenStack.
Yeah.
Right. Mm-hmm. All right. Thank you. Now, when I started looking at OpenStack, Daniel, the first thing that I looked at it was, I was overwhelmed with a lot of, names of a lot of OpenStack projects, right? Mm-hmm. There was this Nova, there was this Neutron, there was this Cinder, and a whole lot of other, lingos that I need to learn with a lot of projects around OpenStack. Right. Mm-hmm. And I didn't even understand how these things are working together and how this would make me give a private cloud. Right. Mm-hmm. Now, if you look at, when you start off with VMware and, the core functionality of VMware that enables you to build a private cloud, which we talk about vSphere. Right. Mm-hmm. I just need to only look at two components, basically at its, core, which is, the hypervisor. So when I go ahead and install and configure and manage VMware vSphere-based private cloud, I take a bare metal or a group of bare metal machines. I install ESXi as the hypervisor, right? Mm-hmm. And then once I have ESXi as the hypervisor, right, then, that is kind of the compute nodes. And then I go ahead and have a control plane, which is vSender, right? And then once I have the control plane vSender configured, then, I manage these compute nodes with the vSender, and that's it. That is the manual way of installing, configuring, managing. The most simple form of VMware vSphere based cloud. And if I need to go automatically, so that is the manual way I was just telling, right? But if I need to automatically go and install, configure, manage VMware vSphere based cloud, then I have SDDC manager. And using SDDC manager, I will go ahead and automate the build of the hypervisor and the control plane. and if necessary, even the advanced services like networking, storage, etc. Right? So could you please how should I be looking at the so many projects, and do I need to install, configure, manage each of those individually, and then connect and make it configure and function these individual units, the project names that I just mentioned, to make a functioning OpenStack cloud?
Yes, that's a good question, Shiva. Yes, OpenStack was built by design like that, with the various dedicated components for dedicated features. But I like to do the analogy with an operating system. So if you look at the Linux operating system, which is in concept close to an OpenStack solution or an OpenStack platform, you have also various components within the Linux operating system, right? But at the end of the day, you have also the concept of distribution, right, where you can have all the different components that are integrated properly together within a given distribution. So for OpenStack, it is similar. We, for example, at Mirantis, we have been doing OpenStack since the beginning, and we have built multiple distributions. So we started with Fuel at the beginning, Fuel-based distribution. Then we moved to Salt Stack-based distribution. And now we are at the ultimate form of our distribution, which is OpenStack that runs on Kubernetes, right? To leverage all the lifecycle management system of Kubernetes. So this is an off-the-shelf solution. You don't need to then start to look at how you are going to integrate all these pieces together. It's all completely integrated. And this is a ready-to-use platform. As you rightly said, you have a lot of automation also around how you're going to manage the hardware, how you're going to set up the cluster itself, right? So again, it all depends on the distribution that you are selecting. For example, again, in ours, Mirantis OpenStack on Kubernetes, what is happening is that we have built a lot of automation also around the onboarding and provisioning of hardware. So we would take the hardware, we would install the operating system, we would install the underlay management layer, and then we would deploy the OpenStack components. As you rightly mentioned, Nova for compute, Neutron for network, Cinder for storage, and then all the other services, and to have that ready to use after a couple of hours, depending again on the size of the cluster, right? So very similar concept to VMware at the end of the day.
All right, thank you. But let me ask you one other basic question, Daniel. So you mentioned that you have these components packaged as part of the distribution, and then you deploy it either manually or, in this case, automated, right? But where do I log in to start consuming this? For example, when I mentioned the control plane of VMware vCenter as the control plane, right? I just vCenter has a UI, which is the HTML5 UI, which is a web-based interface, and you log into the vCenter's HTML UI interface, and then what you do is that you start configuring whether it is compute, network, storage, or anything, and then or even integrating with any kind of authentication backends or the various other configuration that you need to get started, image management and whatnot, right? Whatever is needed to make the cloud functional, that you start configuring step by step through a beautiful web UI, which is the VMware vCenter UI, right? But there are so many projects that I see here, right? Do I need to individually go into each of these components to start configuring? I understood that you said that this is all beautifully packaged as part of the distribution, but where do I start? Where do I log in? Where do I start configuring the compute, network, storage, and a whole host of other things to get my cloud functional?
Yeah, so OpenStack did not reinvent the wheel also there. So it's all based on RESTful APIs. So we have that northbound API, which exposes the various services, compute, network, storage services. Through these APIs, Horizon has built an interface, a default interface, which is called Horizon. So this is the default UI that tenants, users would be using and access their resources given the level of privilege they are provided. So whether they are admin, whether they are simple standard users, whether they are admin within a tenant, whether they are users within a tenant, etc., right? These APIs are also usable by a CLI tool. The default CLI tool is based on Python. And again, through this Python CLI, you have the ability to manipulate all the various objects of OpenStack. And then you have also the infrastructure as code concept, like Terraform, for example. You have a cloud provider, which has been developed by HashiCorp, maintained by HashiCorp. And basically, you can also then write your deployment, your workload deployment, using these Terraform templates, right? So API-based, RESTful APIs, UI, CLI, and cloud providers made available.
All right, that is very interesting to hear because you were mentioning that tenants and users and so on, and the administrator uses the same Horizon UI to log in and do their respective jobs, which I think kind of implies that there is some kind of multi-tenancy, but we could talk about that in a little more detail, right? But as we go through the session, but I kind of understand that Horizon is the UI through which I have to interact to get my job done based on whatever role that I have to, right?
Horizon would be the default. Agreed. Horizon would be definitely the default one. But we also see some of our customers write their own UI because they want to have a custom experience. So basically, they would then write their own UI and then have that integrated with the OpenStack APIs.
All right. So using these extensible APIs that you mentioned just now.
Yeah. And it's all open because it's at the end of the day open source. So documented and open to anyone that wants to actually write anything on top of these APIs.
All right, Daniel, as a VMware person, right, there are a lot of features, whether it is compute, network, or storage, that we keep very close to our hearts, right? And let us try to go ahead and discuss a little bit about these in a very structured manner, right? And starting with compute, right? Now, as I mentioned, when we start configuring these ESXi, which is the hypervisor, and then manage it using the vCenter as a control plane, right? We have this capability to group these hypervisor hosts as something called as a cluster, which is called the vSphere cluster, right? And one of the requirements for this vSphere cluster is to have a shared storage so that you could have some of the key features, key compute-related features enabled on this cluster, right? And, these clusters are created not only to just make these features enabled, but it could also be considered as a set of compute hosts that have the same kind of hardware. And if the underlying physical design is appropriate, this could also be considered as a failure domain and so on, right? And some of the features that we enable on this is called high availability for virtual machines, which is called the vSphere HA, that enables high availability of virtual machines running in this cluster, right? And for example, the cluster obviously needs to have a shared storage, right? For high availability of virtual machines to function so that the appropriate, storage will get attached even when the virtual machine get restarted and so on, right? This is for providing high availability for the virtual machines, right? Then we have another feature called vMotion, right? Which allows you to move, right? If I may say, live migrate one virtual machine from one ESXi host to another ESXi host, right? Either manually or automated, right? So what I mean by automated is there is a functionality called DRS, Dynamic Resource Scheduler, which analyzes the load of the the load of the hypervisor host in the cluster and automatically migrate these workloads. So I actually spoke about three key features here in vSphere cluster that you enable, which is vMotion, which is equivalent to the live migration. It could be manual or automated. Then it was vSphere HA, which is the high availability of the virtual machines. And not to be confused, so I don't want it to be, I want to be very clear. This is about high availability of the virtual machines in the hypervisor cluster, right? This is not about high availability of the control plane as such. By default in VMware, when you deploy a vSphere-based cluster, we don't have high availability for the control plane, right? We have to add additional configuration, pay some extra licenses, and so on to get the high availability for the control plane, which is called vCenter HA, not vSphere HA. So could you compare and contrast some of these key features, whether and how it will be made available in OpenStack, please?
Yes. So you did share a lot here, Shiva. So let's go step by step.
Right.
You did mention cluster, for example, and in OpenStack we have concepts. So cluster, this is where you are grouping your nodes, right? And through this grouping, you are able then to schedule workloads specifically to this compute grouping.
That's right.
In OpenStack, we use similar concepts. We would attach labels to or metadata to servers. And based on these metadata, we can apply some affinity/anti-affinity rules, right? So there are various ways to do that. You can modify the scheduler by applying filters, for example. One of a very simple example is if you want to dedicate nodes for Linux workers and dedicate nodes for Windows workloads, so Linux VMs and Windows VMs. In that case, you would have that specific filter in Nova scheduler that will allow you to do that, just to avoid having licensing issues with Windows VMs, right? Because as you know, if you are scheduling Windows VMs on some compute nodes, then you need to pay the license on the whole host. So that's
we also have the affinity and anti-affinity rules.
That's based on the affinity and anti-affinity rules. But you also have the concept of availability zones. So this is something which is by default in OpenStack. It typically aligns. So this is a logical concept in OpenStack, but that you need to map then to a physical concept, right? So for example, you can have availability zones based on racks, on rooms, on data centers, physical data centers, right? And across these availability zones, then the users will be able to schedule per availability zone. So they can select when they schedule their workload on which availability zone they want to deploy their workloads, right? So this is under a single control plane, and then they have that capability to select where they are scheduling their workloads. And then the last one is host aggregate. So it's similar also to availability zone in the sense that again you are able to select the nodes. Host aggregate is an admin level configuration, unlike AZ. So basically, only admin will be able to define these aggregates and make them available to users. But host aggregate basically at the end of the day relates to physical properties, right? So for example, if you want to differentiate servers with different network interfaces or different CPUs, AMD versus Intel, or you want to have dedicated nodes for GPUs and vGPUs, then you can use these host aggregates so that when you deploy your application, you are able to deploy them on the proper physical servers, right? You also mentioned vSphere HA. That also would come through out of the box in Mirantis OpenStack for Kubernetes. And how we do that is we integrate a component which is called Massacre, right? So Massacre would work with Nova scheduler and will be monitoring the virtual machine. So you can have various levels of monitoring. You can monitor it at the server level. So is the server available or not? For example, you can have network which is completely cut. So basically then the server is not available anymore, or you have another hardware issue. You have a monitoring at the operating system level. You have a monitoring at the hypervisor level. And then you have a monitoring at the virtual machine level, right? So you can define some health checks so that Massacre would monitor these virtual machines. Out of these different levels, then you can define a policy whether you want to recreate or not that virtual machine. So it's not moved. Yeah, yes.
Quick question here, Daniel. So you mentioned Massacre. Is this something I have to deploy extra on top to enable this, or is this available by default, right, to enable the workload high availability?
Again, it all depends on the distribution. But if I talk about Mirantis distribution, this would be made available out of the box. Then within the configuration, you can enable it or not, right? So this is an entry line in the configuration file, Massacre on, enabled, or Massacre disabled, right? And then you can then define the rules around how you want to handle the virtual machine high availability. But this is a very, this is quite concise in terms of definition, so it's not very, very complex, and it is quite easy to understand in terms of format and language and syntax. So yes, around these, the way that it is then redeployed, it's not moved, because basically, yes, you would understand if a server is not available, it would be impossible to move that workload from one node to another. But it's recreated, and then if you have persistent volumes, for example, it is reattached to that persistent volume. So you don't lose any persistent volume, only ephemeral data is lost, but that's the nature of that type of data. You did mention vMotion. Again, in OpenStack, you have the concept of live migrations. You have cold migration and live migration. So vMotion would be closer to live migration. Whenever your workload has shared storage, whether it is shared ephemeral storage or shared persistent storage, live migration is made a little bit easier because it's just moving a virtual machine. So it's a copy of the virtual machine with the state of that virtual machine from a node to another node, right? And then the persistent
very similar. Yep.
Exactly. Very, very similar to vMotion, right? And this is actually how typically we would do updates and upgrades of our clusters before upgrading a node where we know that we will have a reboot. To avoid any impact on the workload, we would evacuate that node, and the evacuation is relying on live migration, right? So this is a robust feature. And finally, you mentioned vSphere DRS. So this is, yeah,
go ahead, Daniel. Yeah, I'm listening.
So you did mention vSphere DRS, and I know that this is a key feature in VMware, right? And a lot of customers I work with typically ask us how we are going to support that. In OpenStack, that has not been something that has been required very, very often, right? Very openly here. When you look at how customers have been, or the market has been consuming OpenStack, they really didn't use that concept of DRS. The capability to modify the scheduler or manage host aggregates and AZs and have also live migration was enough for many of the use cases. However, if you do want to have that type of capability, there is a project called Watcher, which allows to do workload balancing, right? So this is something that today we are in the process of integrating to be able to kind of help, enable the admins to also be able to select which, zones within a cluster where workloads can be migrated. Again, very similar to Massacre, based on some rules, right? Because Massacre and Watcher at the end of the day are extensions of Nova. in the way that the workloads are handled. And thus Watcher will work with Nova so that the workloads are able to move under certain conditions, right? Finally, you mentioned that control plane availability. This is not something which is default in VMware, right? And you would need to kind of add extra configuration to have control plane HA for VMware.
That's right. And we need to buy additional licenses for doing that, right? And we need to do some extra configuration and some advanced configuration after deploying to make it available. Yes, you're right. Yeah.
All right. Okay. Well, for Mirantis OpenStack on Kubernetes, this is completely different. This is out of the box. This is the default configuration. Each and every production environment that we'll be deploying will be having control plane high availability. And actually, we can dedicate nodes for specific functions and always in HA, right? And this is key because if we are to do updates and even in running upgrade mechanism, this means that we need to have multiple nodes to serve the service, right? And then start to upgrade each of the node one at a time. So this is out of the box, and we don't license anything extra. And actually, we don't have any licensing as OpenStack is open source. We only have support subscription, so we don't have any extra licenses on top of the control plane high availability.
That is very good to hear, Daniel. So it seems that most of the features that we hold close to our heart when it comes to compute can either be achieved in OpenStack, either out of the box or with some integration with some projects that you mentioned, right? Yeah. Before I quickly move on to some thoughts around networking, I also saw, Daniel, that OpenStack supports multiple hypervisors, right? Whereas that's a point that I missed to ask, but I just wanted to bring it up before we move into networking, right? Multiple hypervisors, but in case of VMware, it is ESXi, right? But does this mean that I need to also be choosing my hypervisor, or when it comes to Mirantis, there is a default choice there?
Yeah, you're right. OpenStack would through the abstraction mechanism, whether it is for compute, network, and storage, there is that concept of abstraction and being able to expose a similar API. So that's where we were talking about the RESTful northbound API earlier. But then under the hood, you can have various backends, right? You have KVM, you have Xen that can be used. You even had a flavor where ESXi was also managed by the OpenStack APIs. But with Mirantis, by default, we would be using KVM, right? And this is a robust solution which is on the field for a long time. We have been rolling out KVM for all our customers for more than a decade now. And we never got into any massive issues, right? So for us, this is a rock solid solution on which we would rely. So no, you don't need to select the hypervisor. This is provided out of the box through our distribution, and this is also supported by our support team.
Excellent. That's good to know. And does this imply that you will only support a certain kind of workloads, or all distributions of Linux and Windows, etc., are supported as well, right, as guest workloads?
Yeah, we align with the compatibility list of KVM. So this is public again, and we have that full list of the various distributions, whether it is Linux, Unix, or
Windows.
And various versions of Linux, various distributions of Linux, and various distributions and versions of Windows. So again, yes, we would align with these with that compatibility list. Most of our customers would run both Windows and Linux workloads within their clusters, and various versions and various distributions, right? So you have that full compatibility list which is supported.
All right, thank you, Daniel. Then let us quickly go into some of the networking concepts, and there's quite a lot I wanted to ask, but since time is limited, right? The first thing that comes to my mind when I do configure networking in VMware is that in vSphere, if I use vSphere networking, I do not have to worry a lot about complex networking that I need to get my solution to work with. First of all, I like the simplicity of vSphere networking, which basically allows you to configure data center VLANs directly exposed to virtual machines, called a concept called virtual switches and port groups, right? So you have this concept of virtual switches in ESXi, which is managed also by vCenter, right? You create these virtual switches and you expose data center VLANs through a concept called port groups aligned to the virtual switches, and you expose virtual machines directly to the data center networking, right? My first question that comes into my mind is that, do I need to worry about complex overlay networking and a lot of, which we will discuss in a moment, but can I simply expose virtual machines to data center VLANs? This is the first question that comes to my mind, right?
Yes, and that's how many of the telco providers actually use OpenStack. For simplicity, they want to use OpenStack to run the VMs, but then directly expose that to the underlay network. And OpenStack has been built to kind of manage the network in a very similar way as you would do for physical networks, but on a virtual layer, right? So in OpenStack, this is called that concept is called provider network. You would have admins that would create these provider networks, and why this is an admin-related task, simply because this is related to physical interfaces and the physical interfaces that are properly connected to the proper switch ports where you have all the VLAN and trunks configured. And then the administrator of OpenStack, once they have created their provider networks, they can then share these networks through the RBAC mechanism to tenants, right? So some tenants can have access to some provider networks and some other tenants to other provider networks, for example, right? And these provider networks are flat networks or VLAN-based networks, and it's self-serviced. So whenever a tenant with proper privileges would want to create their virtual machines, they would create their virtual machines, attach that to an available provider network, and then automatically, and you don't have all that concept of vSwitch, port groups, and all that. Everything is done under the hood, so you don't need to create all that. Basically, what will happen is that virtual machine will have a virtual port attached to a virtual bridge, and that bridge will be also hosting the physical interface towards which the packets will be received and transferred, right?
Very similar, Daniel. Thank you for clarifying that word, provider networks. Very similarly, the administrators in VMware create port groups, which is going to be consumed by, virtual machines get attached to port groups. And port groups is the definition that is associated with a particular VLAN in a vSwitch, right? So very similar, but I'm happy to hear that there is something that you can easily use for data center VLAN based networking, right? I also wanted to bring up another feature called distributed switches or distributed vSwitch, right? So what in the past, before distributed vSwitches distributed switches were enabled, you had to go into each of the ESXi hypervisor host and you had to create this vSwitches manually, and then you needed to have that port groups associated with them. But with a distributed switch, Daniel, at the control plane level, we can actually create this vSwitch, and then it propagates that configuration across all hypervisor hosts, and automatically hidden vSwitches are created. And then you have a centralized way to manage these, this VLAN based mapping for all the ESXi host or the hypervisor host in the cluster at a central level, so that you don't have to do manual configuration at each hypervisor host, right? So when I use the provider networking concept, do I need to do it at each hypervisor level, or is it done at a central level like distributed switch as well?
Yeah, since I've used OpenStack, I've always known that concept of distributed switches and even distributed routers at the hypervisor level, depending on the software-defined network solution that is integrated into OpenStack. So I've never configured node per node, actually, right? So again, I've always used that central point of access and management. In OpenStack, you have the concept of neutron plugins. So this is the ML2 layer, basically. And through that ML2 layer, you would then integrate various software-defined network solutions. You have a default one, which is OVS. You also have now OVN. You have Tungsten Fabric.
Could I stop you there for a minute? Just a second, Daniel, please. So before we go into the software-defined networking, but the provider-based networking can also be configured centrally. Am I right to assume that?
Yes, the provider networks can also be configured centrally, as long as the configuration is consistent, right? So, for example, when we will be configuring the provider networks, we will indicate on which physical interface the traffic will be going out. So all these machines will need to have the same interface name. As long as we can guarantee that, and that's typical, that's something that basically we can guarantee, right? Because we can manipulate the name of these interfaces. So that's, again, an admin level configuration. Once we are able to guarantee that, you have that single point of management, which is Neutron. And through Neutron, you will be able to manage and manipulate all these connectivity configuration for your virtual machines.
All right. Could I then just go on to some of the advanced networking concept, right? So at the basic level, we consume VLAN-based networking, as I mentioned, and whether it is using standard vSwitches or distributed vSwitches. But if we want to have some of the advanced networking functionalities, we can go and buy an additional licensing for something called NSX. It is very beautiful, right? It allows you to have overlay networks, right? For segregating east-west traffic with north-south traffic, right? And then you could have logical routing, because when you have multiple VNIs available, you need to have logical routing enabled, right? And then it also offers microsegmentation, where if virtual machines running on the same subnet could be could be firewalled as to which ports they need to communicate, etc. Right? And then there are advanced services like load balancer as a service, DNS as a service, and so on, whereby all of these features can be enabled and consumed when NSX is integrated with VMware, right? VMware vSphere. In the past, it was called NSXV, and now it's called NSXT, right? So, is there can I apart from the provider networks, right? Can I have these kind of advanced functionalities in OpenStack, right? Very, very clearly on, overlay networking. I would be interested in overlay networking, logical routing, microsegmentation, especially because most of our use cases with NSX in the vSphere world started with microsegmentation, because we wanted to limit which virtual machine can communicate with which another virtual machine. For example, app web, in a three-tier stack of an application, web can communicate with app, and only the app can communicate with DB, and so on, right? So could you give some ideas around how to achieve this advanced networking functionality with OpenStack? Do I need to buy anything extra? What is it, and how to go about, right?
Yeah, that's a good point. And so you did mention NSX for VMware, and this is what you would be buying, right? Extra licenses. The advantage of OpenStack and as being an open source solution, it kind of opened the doors to multiple parties, whether again other open source communities, or even vendors to come and integrate their solution into OpenStack. So you have various capabilities in terms of software-defined networking in OpenStack. You can have the default solution, as I started to highlight earlier about OVS, so Open vSwitch. You also have OVN capabilities now. You have Open Contrail or Contrail from Juniper. You now have Tungsten Fabric, which is a rebrand of or a fork of Open Contrail to provide also software-defined networking capabilities. And even Cisco integrated their solution with their ACI solution into OpenStack, right?
All right, interesting.
You do have these various capabilities. Yes, you have a question?
No, I said interesting, which you mentioned that not only these open solutions, but even proprietary vendors can have their SDN integrated with OpenStack. Quite cool. Yeah, but please go ahead.
Exactly. So again, depending on these solutions, you have various capabilities, right? With ACI, you can have some segment routing, for example, define and all that. We in Mirantis, by default, we would be integrating open source components because we rely massively on open source, and we want to work with open source solutions to reduce any lock-in into a specific solution. So that's why we would prefer to we have that preference of using open source components. We integrate two software-defined network by default. So OVS is one. And Tungsten Fabric is another one, right? Obviously, you can't use both at the same time, so you need to select either OVS and Tungsten Fabric. And depending on the software-defined solution that is selected, you have various capabilities, like, for example, overlays, VXLAN and GRE are supported by OVS, and Tungsten Fabric will also support MPLS over UDP and MPLS over GRE, for example, right? So this is out of the box again. You just select the software-defined networking, and you have overlay networks made available with a multi-tenancy capability, right? In terms of logical routing, the same. We can do logical routing both with OVS and Tungsten Fabric. We have both the north-south routing capability with NATing capabilities. We have east-west routing capabilities with, again, the capability to do distributed virtual routing. We can also do some advanced networking around logical routing using MPBGP and route targets with BGP, basically BGP protocol to do features or to enable features like layer 2 EVPN or layer 3 IPVPN, for example, right? Think about if you want to stretch networks between tenants or stretch networks between regions, whether it is L2 networks or L3 networks, you can do that using these BGP capabilities, right? So it's VPNs that you can set up. It's not secured VPNs like ciphered VPNs. It's only BGP VPNs, but you can add extra IPsec capabilities on top of that to secure that BGP VPN, right?
All right. Yep.
Micro-segmentation is key also in OpenStack. You have a default mechanism across all these SDN solutions, whether it is OVS and Tungsten Fabric. This is called security groups, right? So you have security groups. That's a default mechanism supported by Neutron. There you would be setting your rules on a layer 3 or layer 4 parameters.
All right. Yep.
You can filter IPs, protocols, and ports, and then control the traffic or control the connectivity between the different tiers. So as you said, between the front end and the mid to the database, for example, right? If you select Tungsten Fabric, you have extra objects that Tungsten Fabric would support. So you would have network policies, for example. You can set your network policy rules and ACLs there, but you also have application-based security policy. So in that case, this is per application, and you can set your network policy, security policies there, so that you have a per application ruling. Okay. You mentioned LBAS and DNS as a service. That would also come out of the box with Mirantis distribution. So LBAS, we have a component which is called Octavia, and with Octavia, you can then have load balancers that would do layer 4 load balancing up to layer 7 load balancing. We can terminate TLS, and we can be in pass-through mode for TLS traffic. So, and again, we have a default backend for Octavia, but we can work with other backends if required, right?
All right. Yeah.
DNS as a service. This is also a standard component that we would deliver through our OpenStack component, whether it is OVS or Tungsten Fabric. We have different capabilities across these two SDN solutions. But at the end of the day, you can use it as a primary DNS or a secondary DNS, or just as a proxy towards your primary DNS, right? When you create your virtual machines, these entries will be directly populated, and you will have your records populated in these
DNS servers as well.
Right? So again, this is out of the box.
Yeah. So if I may ask you, you kept mentioning OVS versus Tungsten Fabric, right? So which means that in order to get these advanced network functionalities, I need to use either of these plugins that works behind Neutron, right? Whether it is OVS or Tungsten Fabric. Am I allowed to choose, as a customer, am I allowed to choose between these? Or therefore the features will differ, and do I need to pay separately depending on what I choose? How does it work, Daniel?
Yeah, so definitely you can choose. You can choose whether you want to use OVS or whether you want Tungsten Fabric. As I said, per region, per OpenStack region, you will only have one SDN enabled. So if you are hosting multiple OpenStack regions, so OpenStack, and what I mean by an OpenStack region is an OpenStack is a region with an instance of control plane, of OpenStack control plane. So that's what we call an OpenStack region. Within that region, yes, you would have one single SDN. But if you are having multiple regions, then you can decide to have one with OVS and another one with Tungsten Fabric, right? You don't pay extra whether you are using OVS or Tungsten Fabric. In our subscription model, we only the model is node-based, right? So you only pay with on the amount of nodes that you are using. And not on the features that you are using or enabling, right? So all the things that I've said, whether it is provider networks, whether it is live migration, DRS with Watcher, or now here overlays, LBAS, DNS as a service, micro-segmentation, and all, this is all included as part of the support subscription, because these are the features that we support in the product. But you don't need to pay any extra, as for VMware, any extra licenses to get these capabilities.
So just node-based licensing, and I get all the compute features and networking features that we discussed.
Compute, network, storage features, yes.
All right, excellent. I'm interested. We'll look at some of the storage features in the next slide before deciding what we get out of the storage features as well, right? But before we move into that, two key items I wanted to clarify here is that we spoke, even in the compute, we spoke a little bit about multi-tenancy, right? So could you quickly share a little bit about multi-tenancy? What exactly is it? Does it mean that you can have a logical segregation of your OpenStack cloud that could be consumed by multiple tenants, and each of these tenants could have overlapping networks, etc.? So and they will interact with OpenStack using the same, because you mentioned also when we were discussing about Horizon interface, you mentioned that administrators would have interact using Horizon, operators will interact using Horizon, and even tenant users will interact using Horizon. So could you please very quickly share how this multi-tenancy is achieved in OpenStack, please?
Yes. So yes, if you look at some other cloud concepts, multi-tenancy is typically attached to networking. So that's most probably why you wanted to talk about multi-tenancy when it comes to networking. In OpenStack, it's a bit different, because the multi-tenancy is spread across all the different components. So you have the notion of project, and that's the base of all, right? And within that project, then you can access various objects of OpenStack, whether it is the image store, or whether it is virtual machines, networking, and storage capabilities, right? So within that project concept, then you can create within that project, if you have proper privileges, you can create your virtual machines and then create your own networks. And by default, all of this would be kept within that project level, right? So basically, when an administrator will create a project and give you the right to read and write within that project, then you can have that capability to create your virtual machines within the project, and then create your virtual networks, create your virtual subnets, your virtual ports, and then attach all that to your workloads, and also do the same about storage with your volumes. Okay. If
quick question there, Daniel, if I may interrupt you, sorry. So what are the control frameworks around it? Can I consume unlimited number of virtual machines, network, storage, etc.? Or what is that the administrator configure some kind of limits around who can get what, how much can they get, and so on? What are the control mechanisms when you enable this multi-tenancy?
Yeah, you have the quota concept. So within the quota, then you can define various parameters. You have quite an extensive list of parameters that you can define within the quota, like virtual machines, memory, CPU, volumes, snapshots, networks that you can create. And you can only create within that quota, right? So basically, and the administrator, whenever they will create that project, they will assign a quota to that project. All the users that are then assigned to that given project by default will share that quota, right? But you can also set some quota per user on a per user base if required.
All right. So in the interest of time, Daniel, I'm going to very quickly, if you could tell a little bit about how the, DPDK integration, SmartNICs, and how SRIOV, etc., are enabled in OpenStack very quickly before we go to storage. Then we can, go ahead and discuss storage after this. Yeah.
Yes, sure. So as I said, when we talked about provider networks, OpenStack is quite popular in the telco space. And in telco space, if they are to run virtual machines for networks, so what we would call virtual network functions, VNFs, then we would need to leverage things like DPDK, for example, right? So software-based, user plane, accelerated stack, network stack. In that case, with OpenStack, you have all the capabilities to enable virtual machines to run DPDK. We would leverage SRIOV. We are compatible, so OpenStack is compatible with Intel Enhanced Packet Awareness Platform Awareness Framework, so EPA framework. We would be able to allocate huge pages to virtual machines. We would be able to do CPU pinning and manage the NUMA awareness of the nodes for Intel architecture, so that you can run DPDK properly in the virtual machines without being a noisy neighbor.
All right, thank you. Let's go ahead and discuss a little bit about storage now, Daniel. All right. So when as VMware administrators, when we configure a vSphere based cloud, right, we don't have to worry about what kind of storage that we want to work with, right? There is an extensive ecosystem of partners that we can choose from, right? We could go for fiber channel based storage backends, iSCSI based storage backends, and for some of the non-production environments, we can even use NFS based storage backends, right? How this is basically done is because VMware has several levels of abstraction, right? When storage comes in. So this particular storage is, let me give you an example of fiber channel storage, right? When this particular storage is exposed as through the appropriate LAN masking, zoning in the SAN switches, etc., you can expose the LANs to the ESXi host using the fiber channel HPAs, and then you format these fiber channel LANs, for example, that is exposed to the hypervisor host. Using you format these LANs using a particular file system, a clustered file system called VMFS. Once you format this clustered file system, the LANs using this clustered file system, right? Why I say clustered file system? Because multiple hypervisor hosts can look at the same LAN, do read-write operations to this LAN. Once it is formatted, they become something called as VMware's data stores, right? Into these VMware's data stores, you can have one data store, multiple data store, a collection of data stores, etc. Right? Into this data store, you keep your the VMDK, which is actually a file from VMFS perspective, which is actually providing the block storage to the virtual machines, right? Because of these several levels of abstraction that I mentioned, right? The VMFS, clustered file system, and VMDK, etc. Right? There is a possibility to have multiple storage backend enabled for the hypervisor host, right? So, may I know how does it work in OpenStack, please?
Yeah, sure. In OpenStack, you have something again very similar to the networking concept. You have something which is called Cinder. So Cinder, as any of the I would say OpenStack components, is based on API, scheduler, and attached to a database with database entries, and then also is able to manage messages within the message queue, right? And Cinder has that plugin mechanism. You can attach various storage backends to Cinder. The same as for software-defined networking concept, multiple vendors came with their software-defined storage systems, whether it is NetApp, HP, Pure Storage, for example, Fujitsu. They all came and added and built a Cinder plugin or a Cinder driver, which could then be integrated within that Cinder framework, right? So this means that you can have, again, multiple backends based on multiple technologies, whether it is FC, whether it is Fiber Channel, whether it is iSCSI, or even NFS-based backends, right? We, by default, we would support Ceph because it's open source. We even support Ceph as standalone solutions. So for some of our customers, they have Ceph-only solutions, and we support that for them. But
what does that mean, Daniel, by standalone? Which means that you can only deploy Ceph as a storage product separately from OpenStack. Is that what you mean by standalone?
Exactly. So Ceph only, without all the compute and networking, right? Only to be used as a storage backend. But we then also integrate that with OpenStack, right? Through, again, that Cinder plugin mechanism. And through that, then we can offer, we would be able to create a virtual a volume, right? Using the RBD driver, we would be creating volumes on the Cinder on the storage backend, on the pool, and then that volume, that logical volume, would be mapped towards a KVM device for persistent volumes.
And does this work similarly for the Fiber Channel iSCSI storage as well? Does it work also depending on the Cinder plugin mechanism that you have shared? So it does not matter. Are you saying that it does not matter whether it is provided by Ceph or it is provided by any of the supported storage backends, so long as the vendor provides a Cinder plugin or a Cinder driver, right? The volumes would be magically provisioned and attached to the virtual machine, and we don't have to worry about how it happens underneath.
Exactly. It's the same mechanism. You have that northbound API which is exposed through Cinder. You would consume volumes through Cinder, and then under the hood you would have the driver plus the configuration that comes for that specific backend that would be handled by that integration plugin mechanism in Cinder.
All right. Could we touch upon very quickly on storage migrations, right? So because as I mentioned, right, because of the flexibility to have multiple storage backends in VMware vSphere, right? You could today be working with a storage vendor A, right? But due to whatever reasons, you could go into a storage vendor B, or even during hardware refresh cycles from the same storage vendor, right? You could migrate the block storage of these virtual machines from one version of the storage vendor to another version of the storage vendor, right? Could you explain, how do we do that migrations in OpenStack, please?
Yes, you have that capability also. This is related to Ceph, and the capability of Ceph to take volumes from one given backend and then move that into Ceph storage. So this is again part of the capabilities of Ceph to kind of rebase the volume of the data from a given volume. Existing volume from a given backend towards a Ceph volume, right? So this is available in Ceph. You can configure Ceph to enable that, to do that data migration. We also have another concept in Ceph, which is RBD mirroring. This is important if you do want to have your data replicated from a given region to another region, right? So let's say you want to have a one direction replication. In that case, for that one direction replication, you would have a primary site and a secondary site, and then you would migrate data, or data will be copied, will be mirrored automatically from that primary site towards the secondary site, right? So this is again on a backend configuration level. It's not related to OpenStack, but it's related to the storage backend at the end of the day, right? If you're using pure storage, they also have replication mechanism like that. If you're using NetApp, they have also their own replication mechanism like that. So we would just be able, but here I'm talking about Ceph because this is the default solution that we would support in our distribution, where you are able to do these type of mirroring, whether it is synchronous or asynchronous mirroring. Right.
Yeah, but I also heard about this. Some of these Cinder drivers also support volume migrations, right? So which helps to migrate volume from one storage to another storage. So you're essentially saying that so long as the Cinder plugin
exactly
supports it, then you could do that. Yeah.
Exactly. This is all related to the capability of the Cinder driver to support that and move data from a given volume to another volume.
All right, thank you. And Daniel, sorry that I'm asking a lot of questions.
No,
I wanted to understand this in deep, so that to see whether whether OpenStack could give me a real alternative to my VMware vSphere platform, right? I noticed that because of a lot of questions and the detail with which you're answering these questions, right, we are overshooting by a couple of minutes, but I hope you have some more time to explain some of these topics that I'm asking you, right?
Yeah, I do have the time, and I'll try to give you as much information as possible. You're right. I think OpenStack and VMware are different, but at the end of the day, you can achieve the same thing, right? And here, yes, definitely, let's cover the different topics so that we can see how we can achieve the same use cases using a different technology.
All right, thank you. So let me. We were talking about fiber channel storage, iSCSI, and different kind of backends, right? This was all. This was and is good with different kind of storage interoperability and so on. But VMware came with this next cool technology called VMware vSAN, which is the hyper-converged way of deploying VMware vSphere, VMware vSphere-based private cloud. You do not have to rely on external storage vendors to do this, right? So long as you add a couple of disks into the compute host, and then you buy an extra license for this VMware vSAN software, you can magically turn your compute node also into a software-defined storage. and make your deployment hyper-converged deployment, right? Now you tell me, does OpenStack support hyper-converged deployment with Ceph? Is it possible? And do I need how does the licensing works there, right?
Yeah, we would support the hyper-converged model, deployment model. As I explained or talked a little bit about that at the very beginning, we do use Kubernetes as the management layer, right? So as we do use Kubernetes as the management layer for the OpenStack components, we use labels to define where the features, where the components are being deployed and what are the features they are handling, right? So basically in the hyper-converged model, what we would do is we would set the labels, set the tags on the compute nodes as being also a storage node. And in that case, the services for both compute and Ceph would be deployed. So the Nova Compute and also the OSD services would be deployed on the same hypervisor, right? So this is how we are converting that compute node into a hyper-converged node. We went also a step further because it's not only about deploying these services, but it's also about reserving the proper resources for compute and for storage, right? We know that to get proper performance for Ceph, we need to allocate enough CPUs and memory to the disks. And the same as we are going to host virtual machines on top of these computes, we need to be able to allocate enough CPU and memory and disk to these virtual machines.
So quick question there. So when you enable hyperconverged storage using Mirantis OpenStack, you are saying that you are in control of how much resource to allocate for your compute and how much resources to allocate for your storage within the same host in terms of CPU resources, etc. Did I hear that correct?
Exactly.
That's very welcoming to know, Daniel, because when I enable hyperconverged in VMware, I can't do that basically, right? Because I cannot say how much of resources needs to be allocated for compute versus how much it is for storage. Basically, it's up to the system's discretion, right? So I'm very happy to hear that is something that we could do it. And this is something can be fine-tuned using some policies, or how does it work?
Yeah. It can be. It's definitely fine-tuned because we will not treat an NVMe disk the same way as we would treat a spinning disk or an SSD disk. So basically, whenever we have NVMEs, we know that we need to allocate more CPUs, we need to allocate more memory. Otherwise, it's useless just to buy NVMEs. You will not get the performance out of that. And the same for the compute. We know that we can control the overcommit ratio for CPUs. And we can also still leverage the CPU pinning capabilities, right? So that's why you can fine-tune that in various ways. Stability is key. So we will always look at the proper parameters to guarantee stability for both the compute services and the storage services, but also performance, right? So to give the proper performance for the storage and the compute layer.
So how does the licensing model work, Daniel, here? Is it by gigabyte or is it by features, or I can get certain features gigabyte? How does it work, the licensing model for the storage?
Yeah, again, we don't have any licensing. It's all open source. So we only have support subscription, and the support subscription is still a node based, right? So we don't look at the amount of disks you have, the amount of virtual machines you have, the amount of memory or CPU you have, amount of sockets you have. We only look at the nodes, and the pricing for the subscription is node based. So basically, you can architect these features. Sorry?
I'm free to architect it based on my requirements, and all I need to worry about is the number of nodes.
Exactly. You can have big boxes, small boxes, and for us, it's we just don't look at these features that you enable, right? We support all these features as long as it's part of our reference architectures and services we have integrated, tested, and provided.
All right. Daniel, thank you so much. I now have a fair understanding of how it is deployed, how the compute features networking features and storage features fare against OpenStack, right? Now, could we move on to discuss some of the deployment topologies, common deployment topologies that we do? Yeah.
Right. Sure. And just before we move, I just want to highlight something, because we talked about volumes, and definitely that's one of the main services in terms of storage that users will be using or would be using.
Yeah.
But please note also that we provide out-of-the-box object and file storage mechanism, right? So if you want with that single storage platform, you can also have object storage based with S3 or Swift APIs. And you can also have file system as a service, whether it is Samba or whether it is NFS, that you can then, and it's all self-service. So you can create your buckets. You can create for object storage. You can create your buckets, and then you can create your files and add your files and read your files out of these buckets. And then for file system, again, it's self-service. You can create self-service NFS or Samba backends that you would be using and sharing with your different workloads.
And this is possible with the same. This is possible with the same Ceph storage backend, or do I need to configure, or is it separate?
Same. You would have the same. We can dedicate pools for that. You can have different performance layers, different pools. Whether you want to have archival object storage, whether you want to have object storage.
Because why I asked that specifically, Daniel, is because the I/O characteristics of block storage is different from that of file storage and object storage. So when you were talking about pools, you're saying that I can have these pools is a segregation mechanism in Ceph as to dedicate these pools for the particular I/O characteristics that is required for block storage versus file storage versus object storage. That's because it's coming from the same storage backend.
Exactly.
All right. Excellent. Nice to know that, Daniel. All right. So let's move on to the deployment topologies, right? Very, very common deployment topology in VMware that we use is typically active-passive data centers, right? And when you have active-passive data centers, typically your workloads run from a primary data center, and the passive data center is there for in case of DR, right? And you use a separate VMware product called Site Recovery Manager, right? Whereby you would be able to bring up virtual machines from one data center to another data center, either using a software-defined storage replication or either using external storage replication mechanisms that is available from storage vendors, right? But in that is one way of deploying a VMware-based active passive data center, right? And you could also do several things like DR drills or like fire drills, for example. You can simulate for regulated industries. This is very critical, like FSIs, telcos, and all, that you need to show to the regulator that in case of a data center unavailability, right, you can bring up your workloads onto a different network in a different data center and still your business can continue, right? So this is a typical active-passive deployment model. And together with this tool called, or product called Site Recovery Manager, we are able to achieve this functionality, right? And the second, not very common, but in countries and in where data centers are nearby, right, in terms of physical distance, right, with low latency dark fiber interconnect, low latency round trip requirements, etc., round trip latency, etc., right, you could have a configuration called VMware Metro Stretch Cluster, right, which will make, you can do a layer 2 extension of the network, right, and then you can have this virtual machine workloads floating across either of the data center, providing you a disaster avoidance versus disaster recovery, right, which we call as the active data center, right? You need to stress the network, you need to have some storage integration. It is exposed, how the storage is exposed to both the data center depends on the storage provider. and whether it is a traditional storage or software-defined storage, right? So can we have these kind of active passive deployments and have a tool like Site Recovery Manager to be integrated and simulate to the regulators, etc., use when it is active passive? And going on to active, is it possible to have active data center where round trip latency permits? And how? So could you give us some insights into how this works in the OpenStack world, please?
Yeah, sure. So look at if we are going to look at the active DCs, for example, very similarly, we would be able to stretch clusters, whether it is control plane nodes and storage nodes and compute nodes. We would be able to stretch that across multiple data centers, right? Obviously, this is latency sensitive, so 20 millisecond, 30 millisecond round trip time would basically be the latencies that we would be expecting in between the different physical sites. So within a 20 kilometer, 30 kilometer radius, fiber connectivity, and within this radius, then we would be able to again have some of the control plane nodes on some sites, some of the compute nodes on some sites, and some of the storage nodes on some sites, right? Some of the services are quorum based, so typically we would have an impair amount of sites, so 3, 5, 7, etc., just to avoid breaking that quorum mechanism. We don't need the layer 2. We could do also that. We could stretch on layer 3, right? Because today our deployment is on layer 3. So just to reduce the issues with scaling and layer 2. But if you do have these dark fiber connectivity links available, then we'll leverage that for sure. When it comes to active passive, we would also support that. But for that, we work with a partner. That partner is called Tredio. And through that partner integration within our solution, so Tredio integration within Mirantis OpenStack for Kubernetes, how it works is then Tredio would be able to copy the resources, whether it is compute workloads and also volumes, so all the stateful resources, and then sync that to another remote site. We'll also manage all the metadata and sync that towards the other site so that you can, in a case of disaster, you can recover your workloads with your volumes and all that. Some of the things will change, right? Like IP address and all that. So you can't guarantee that you have the same IPs on both sides, but at least your services will be up and running with the proper metadata, security groups and all that, and RBAC rules attached to it. And then you can manage the access to these workloads using external systems like GSLBs and all that.
Mm-hmm. So I understand. I have a fair understanding of active, passive, active data center as well. But what about the remote compute only, multi-ACs and multi-region? What do you mean by that?
Yeah, so there are cases where you want to have central, the control plane centralized. So you have a star topology where you have the control plane in that central big data center, and then you can have edge sites where you have some only compute nodes there, right? So in that case, you don't need to also have the control plane, on these sites. If you don't have enough space, you don't have enough power, you can't have the weight there and all that, then you can only have compute nodes there.
Oh, this could be useful for some edge use cases and
exactly.
so on. All right. Okay. So you have a data center to host your main cloud, and then you have small clouds in the edge use cases, and then they somehow connect back to the centralized data center at regular intervals or something like that.
Exactly. And for the rest, I think it would take a little bit more time to go and deep dive into that. But just for your information, please know that if you want to have availability zones as data centers, so not rooms or racks, you can also have one region and then multiple availability zones, and each availability zone being a data center, a little bit like what you would see also in some of the public clouds. And then the multi-region management is you have one single pane of glass. The way that we deploy today our OpenStack is you have one single pane of glass, and through that one single pane of glass, you can deploy multiple OpenStack regions, right? So you can have a staging region, for example, or any production region or multiple production regions managed that by one single pane of glass.
All right. Thank you, Daniel. Thank you. So that covers some of the common deployment topologies, right? And the last part that I wanted to understand a little bit is because when we started the talk, I was telling that, I was pretty overwhelmed that a lot of loosely coupled projects with a lot of names to remember, right? Is contributing, is coming together to provide these OpenStack private cloud, right?
Mm-hmm.
Now, how do I take care of these, whether it is, updates, whether it is security patches, feature upgrades, product upgrades, from major version upgrades or whatever it is, right? How is, because when it is compared against VMware, right? VMware is a single company, right? That is running various different products, but they are all very well tested and released together so that the interoperability is well tested, right? So how can we ensure that patching, updates, feature upgrades, etc., work seamlessly in this loosely coupled environment, please?
Yes, so we are the same, right? As Mirantis, we would manage our distribution as a product very similarly to VMware. So we have release cycles. We support our releases by default for 2 years. So each and every major release that we provide is supported for 2 years. We would provide every 6 to 8 weeks a new version of the current release so that we are able to ship fixes, patches, security patches, and all that. And we are also very, very transparent with our customers. So we scan our components. We would have that CVE report, and we would share that with our customers using an interface on the support site where they can see the list of issues that we have in terms of security. We have a rule where we would not ship our product with any critical or major CVEs, right? We can ship with some minor CVEs if required, but we would then define a plan to kind of fix them, right? And we have an engagement, or we have engagements with some of our customers to go into that route of having no CVEs at all for the versions that we are providing, right?
So quick question there, when you were mentioning about upgrade cycles and product release cycles, testing cycles, and so on. But I know that OpenStack has very aggressive release schedules, right? I think once in 6 months or so, right? So I don't need to necessarily upgrade every 6 months and continuously be on an upgrade cycle all the time to keep my cloud updated. What is your long-term support strategy and the release cycles? How does it work? Can I jump between releases? You take care of all that? How does it work?
Yes, so by default, our support is 2 years, but we can, and for some
2 years for a given release, you mean?
For a given release, yes.
All right, yeah.
So 2 years for a given release, and within these 2 years, then you have options to update your cluster, right? So it's a moving window. We will release continuously these, and as we release these, we guarantee the upgrade paths, right? So
can I still stay N-1 or N-2 or something like that, Daniel, right? For example, it is yoga, but could I have been in Victoria and then you provide an upgrade path from Victoria to yoga, or how does that work?
Yeah, so when we deploy these releases, they have an OpenStack version that they support. So whether it is Victoria and whether it is yoga, and then whenever you have that new version, that new major version, you have also that upgrade path which is defined, right? So for example, in that case, you are guaranteed to be able to move from Victoria to yoga. We don't include all OpenStack versions because, again, as you said, every 6 months ish we have a new version that we need to integrate. So sometimes we do long jumps, but whenever we do these long jumps, and the reason being we need to harden and make sure that it is properly supported. Whenever we have these long jumps, we again guarantee these updates. Please note that when we have these updates, we update it in a rolling upgrade mechanism so that your cluster is not down. The control plane is highly available, so we do it one by one. And then also for the workloads, we would evacuate the compute nodes. and then upgrade these nodes before rebooting the different nodes, right?
So this is automated. It's an automated process. But what about some control mechanisms there? I may not want to upgrade all the hosts in the same go. I may want to test a few hosts and then go into another set of hosts. What are the control mechanisms there if it is automated?
Same as VMware, you have the maintenance mode. So you can set some nodes into maintenance mode, and then you will upgrade the nodes there first, right? And then only these nodes will be upgraded during the maintenance window. So you put them into maintenance mode, and then you upgrade these nodes. And then in another batch, you would set these nodes under maintenance mode, and then you would do it again.
All right, and this is scheduled and done automatically, yeah?
It's all managed and done automatically, yeah.
All right, thank you so much, Daniel. This was a wonderful interaction with you, understanding and seeing OpenStack through the eyes of how and compare it against VMware, right? Now, if I could go in and summarize some of my key takeaways, right? What I understood from your explanations as a VMware expert seeing OpenStack, I think it is fairly possible for a VMware for people with VMware expertise to understand OpenStack and even build an OpenStack private cloud platform with ease, because you mentioned that it is automated deployment, right? You said that there is something similar to SDDC Manager from Mirantis that brings up all this automation and brings up the entire OpenStack private cloud, right? So it is possible to build it very easy, right? And in terms of various ways to interact with OpenStack, whether it is CLI, whether it is UI, mechanisms exist, right? And then you could fairly have the same kind of or similar kind of feature set, right? It is not. I'm thinking that it is not the feature parity that is important, but how to get similar functionalities that is of interest to the business, and how to enable it using OpenStack is important, right? And that is applicable for compute, storage, and networking also, right? And the various advanced features, whether it was compute, network, or storage, and multi-tenancy, right, etc. All these features are out of the box. You get that by subscribing to simple node-based licensing, whether it is for compute, network, and storage, right? Mm-hmm. And more importantly, you could also deploy a hyper-converged OpenStack platform, right? Mm-hmm. If you do not want to have a storage backend from any of the proprietary storage vendors, right? Mm-hmm. Mm-hmm. That is possible as well. And you could fine-tune how much compute capacity is allocated, how much storage capacity allocated, so that you can get the best storage performance and balance it against how much compute you can pack into the hyperconverged infrastructure, right? Yeah. So some of the key takeaways are, and I think with this, I feel that there is no need for VMware experts to have a fear of OpenStack, right? The knowledge that VMware experts have could be easily translated, because they're already virtualization experts. They're already, whether it is compute virtualization, network or storage virtualization, they're already experts in this area, and their knowledge can be easily transitioned into an open building and running an OpenStack based private cloud. Yes, you need to understand a little bit more about the lingos associated with it, right? But the operating principles, if your foundation is strong, the operating principles remain roughly the same. That is the key takeaway that I have as a VMware expert, Daniel. But could you share some of your thoughts around this, please?
Yeah, I wouldn't have said it better. You're completely right. For VMware admins, I think the concepts are the same. Technology is different, but the concepts are the same. I always have that analogy with operating system. Windows on one side, Linux on the other side, right? And at some point, Linux, people at the beginning was a little bit afraid, but when you consider it as a product And here, OpenStack, you should consider it as a product and not a group of elements to integrate, but have it out of the box, use it as a product, have someone that would be able to give you guarantees, right? Guarantee that you can deploy, guarantee that you can scale, and guarantee that you have all the proper updates and upgrades without a lot of complexity, right? And if you're able to do that, if you're able to take OpenStack as an open source project, but as a product, right? And with the proper mechanism behind, with someone, a partner that can help you to secure it, to make sure that it works based on your use cases, you will be able to achieve quite good TCOs. And that's what we can see with many of our customers, right? They are able to improve massively the TCO, total cost of ownership, by being able to improve and getting guarantees under the hood.
All right, excellent, Daniel. So what are our next steps in helping the VMware experts in transitioning into an OpenStack world, or even the alternatives that we can provide?
Yes, so what we have planned is to do it in multiple steps. So I think the next step would be to have a demo of the day-to-day operations in VMware and OpenStack. So what we could do is take an application and try to deploy that in VMware, and also do that in OpenStack, and see that you have very similar concepts, right? So create a virtual machine, create networks, create volumes, expose these services externally, do micro segmentation and all that, and see how it works on both worlds, right? Then we can also look at and explore how we would be able to migrate workloads from VMware to OpenStack, right? So what are the options for you to start to look at into, and what would be the capabilities options to go into that OpenStack route. And finally, we can be a little bit more disruptive and say, okay, let's look at how or whether that makes sense to migrate also to Kubernetes, right? Because at the end of the day, what would happen is you can kind of do that analysis of your workloads, and then decide to migrate some of them towards OpenStack, and then migrate some of them and modernize them into containers and move them to Kubernetes. So Part 4 will explore that and see how we can also look into this option. That makes sense.
All right. Thank you, Daniel. So that is clear. I think we have extended the talk well by about 30 minutes, but that was quite informative, I believe, to our audience, how VMware and OpenStack can be compared and contrasted, right? And this is going to be a series of talks, right? So please join us, right? And we could take the Q&A at another point of time, or dedicate a complete session for that. What do you think, Daniel?
Yeah, we will definitely do that. So again, thank you very much, Siva, for your the interaction today. Thank you very much, audience, for your time. I hope it was useful, and I wish you a good rest of your day or afternoon or evening. Thank you very much.
Okay, thank you so much. Thanks, everyone. See you again.
Thank you. Bye-bye.